Why do we study the creation of the concept of numbers? Most people today do not have any difficulty using numbers. In fact, it is more difficult not to use numbers. With numbers, people today can figure out how much they possess and compare it easily with the possession of others. When we look at the process through which the concept of numbers came about, we realize that it emerged with the concept of ownership. How is it that we were able to learn of these processes? The answer can be found quite easily by observing how children grow up. Newborn babies have no concept of numbers. Whenever they are hungry or feel discomfort, they just start crying. Mothers would look at the babies and quickly realize the problem. Once the mothers give the babies milk or change their diapers, they quickly stop crying. From babies' perspectives, the mothers would provide them with whatever they want. There is no need to hold on to things they want. However, as babies grow up, they start to develop an obsession toward what they own. A baby that used to be satisfied with a cookie in just one hand would later be at ease only when he or she has a cookie in each hand. The baby realizes that a cookie in each hand means having more. Soon the baby feels that it is not enough to have cookies in both hands. The baby notices the cookies that a sibling is eating and starts to act greedily. He or she now needs cookies in both hands and one in the mouth. However, this does not mean the baby understands the concept of numbers. It is just that having a cookie in one hand eventually develops into a need to have a cookie in each of the two hands. Later, there is no comfort without another cookie in the mouth. The perception of numbers babies develop from a natural need to possess is similar to how crows perceive numbers. Things would have been similar for primitive people. They might have understood the idea of one or two of objects, but anything beyond that would have just been many. If human society had stayed at primitive levels, the concept of numbers would not have developed any further. Animals are satisfied when they have enough to eat. A lion with a full stomach does not hunt even if there is prey in sight. People, however, have the desire to have more and always make comparisons with others to see who owns more. Such desired possessions may be thought of as being the powerhouse of what expanded the concept of numbers to become more comprehensive. Since numbers cannot be seen or touched, people in the past had to use tools from nature to count objects. They counted and remembered numbers by matching each stone with an animal they owned or making markings on a wooden stick for every fruit they collected. Survival was of the utmost importance for the first humans. They hunted or gathered food to solve the problem of eating and surviving. Even when they started to settle, they did not yet have the sophisticated technology for farming, so they moved around in groups and mostly lived in caves. It was rare for them to have any leftover foods, resulting in a relatively egalitarian society. There was no need for numbers or the ability to count. Inequality necessarily requires the existence of someone who has more than others. In other words, it requires that there be things left over from collective hunting after the food had gone around to everyone. Yet, hunting itself was difficult during the Paleolithic era. One false step during a hunt meant the difference between life and death. A successful hunt meant the people would have enough to eat, but failure meant death. The game was divided equally among members of a group, and there was rarely anything left afterward. This created a structure where no one could have more than others, everyone was equal. Art expresses the intrinsic human desires. At the same time, such art intimately related to matters of food and survival, that is, economics. The natural desires of the Paleolithic era had to do with survival. Through the Venus of Willendorf, an artwork from this era, we see that the standard of beauty was extremely different from the one we have today. The large breast and hips, the plump and curvy figure represent how much the mankind of the time wanted more children. The same is true for the Lascaux cave paintings. Every piece of the paintings was wishing for a successful hunt and a large catch. People started to feel the need for numbers in the Neolithic era. Humanity began to farm and domesticate animals for the first time during the Neolithic era. Humans no longer needed to roam the land for food, they built houses near rivers or sea where it was easy to get water and started a sedentary lifestyle. Although the societies were still equal, clans started to form, primitive forms of religious beliefs were born. As humans experienced revolutionary change, where food was obtained through the production of plants and animals, concerns about starving to death largely disappeared. Settlements were mostly near the water, so the bases of the pottery in this time were pointed. The earth by the river was soft, and the areas by the ocean were covered in sand, making the pointed pottery more adequate for keeping upright. Further, humanity began to need more sophisticated ground stone tools, rather than chip stone tools, for better farming. Ground stone tools were made by grounding the rocks finely, making them useful in many more ways than chipped ones. As humans began to raise livestock, they also started making relevant tools, as well. After consuming the meat from the animals they raised, they used the leather from the animals to make clothes. This required threads and needles. Compared to today, the threads and needles were not very sophisticated, but it was enough to make clothes at the time. The farming and domestication of animals during the Neolithic era did not give the people abundance. This was their first time farming and domesticating animals, meaning that they were not at all skilled at them. The actual yield did not at all great, and there was not much left after everyone got their portion of the production. Art was closely related to farming during the Neolithic era. Farming made them realize the importance of the natural environment. In other words, there was much fear of natural disasters, such as droughts or floods, that could ruin the harvest of the year. As the fear grew, the awe towards nature grew as well. This awe became bigger to become a religion. That is how a primitive form of religious beliefs was born in the Neolithic era. One of the artifacts from the Neolithic era includes a seashell with 3 holes on it to make it look like a human face. This is a representative artifact that shows the life of the Neolithic people, how they meant to overcome their fear of nature through ritualistic behaviors. Animism is a primitive religious belief that worships natural phenomena, such as the sun, rain, wind, and inanimate objects like large rocks. Totemism is a religious belief that worshipped animals or plants that could be linked religiously to a specific group or human represented as a totem. Shamanism is sorcery or religion centered around a shaman who communicates directly with supernatural beings. In Korea, a shaman is called mudang. The word muting referred to an individual who connected humans on Earth with the god in the skies. Since when was there a surplus in the yields from farming? The concept of ownership gave way to the need for numbers. With the advent of the Bronze Age, farming technology developed and rice farming began by creating paddies. While dry field farming yielded little, paddy farming, although it was difficult, had great yields when done right. Of course, the continuation of the farming society meant that people lived with a sedentary lifestyle. However, because it was cold near the waters, the people needed a mountain close by to help keep them warm. People started settlements by streams with easy access to water. Living space in the Bronze Age moved from underground to above it. The heater was moved from the center of the houses to the edge of the house, and the base of the pottery became flat so it could be placed on the ground. The development of farming technology meant an increase in harvests, leading to surpluses. Who took the extra harvests? The answer most likely would have been those with power. The one with power would have wanted to own the surplus, which resulted in a need to count what was left after the distribution. Likewise, numbers came about naturally. The purpose of studying this math topic is to figure out how humans and society developed while understanding how the concept of numbers came about. Why did it take so long to recognize numbers in abstraction? Humans use numbers to count their possessions and to determine the order of things. How were numbers, something we use with so much ease today, born? Although numbers look simple and easy, it took a long time to figure them out and start to correspond a number to an object. Of course, the first numbers discovered by humans would have been 1 and 2. 1 represents 1. 1 represented the only person standing or a person standing up straight. 2 represents 2, indicating someone other than the self. However, it was more difficult to perceive the numbers that come after 1 and 2. Such numbers were just seen as many. At a time when humans did not have a clear idea of numbers, the numbers they were capable of recognizing were 1, 2, and many. With the development of human history, the methods of counting developed with it. The first method of counting was pairing objects with each other. Each object was paired with a pebble and counted by lining up the pebbles, or a tree was marked with a line for each object there was. Even when storing the food that was obtained from hunting or farming, people also used pebbles or sticks to mark the amount. Once there were surplus produce after consumption, people started to distinguish between what is mine and others, leading to a natural need for the concept of numbers. For example, suppose we put as many pebbles as there are fruits in a pouch. Every time we eat a fruit, we take a pebble out of the pouch. We can tell how many fruits are left by looking at the pebbles in the pouch. Should there be fewer fruits than the number of pebbles, we could assume that someone had stolen the fruits. The easiest method of counting was to use human body parts, to each of which a number was attributed for counting. The Papuan tribes in New Guinea, located in the South Pacific, counted by designating numbers from 1 to 41 to body parts. Each body part was paired with a number. The pinky finger on the right hand was 1, the ring finger of the same hand was 2, the mouth was 12 and the small toe of the left foot was 41. Although it is not the convenient counting system we are familiar with today, they could still count and calculate up to large numbers using body parts. A shepherd who did not understand the concept of numbers could make sure all of his sheep returned safely using pebbles. Every morning when the sheep went out to graze on grass, the shepherd put a pebble in a pocket for every sheep that left the pen. When the sheep return after sunset, the shepherd took out a pebble for every sheep that enters the pen. By corresponding each rock to a sheep, the shepherd could count the number of sheep. If there are still rocks left in the pocket even after all the sheep went into the pen, the shepherd could immediately realize there were sheep that had not returned. On the other hand, if the sheep continued to enter the pen even after the pocket was emptied, it would have meant a neighbor's sheep had followed his herd or that a pregnant sheep gave birth outside. When the shepherd did not have pebbles, he could draw lines on a stick or an animal bone instead. This shows how people in primitive societies counted by pairing up a pebble or a line with an animal in the livestock. To the primitive people, who did not have numerals or letters, this was the most simple and accurate way of counting. We can find common traits between objects that seem unrelated. For example, 2 sheep, 2 pencils, and 2 cars do not look related, but you can find one thing in common, the number 2. This is the concept of numbers. What distinguishes humans from other animals is that humans can find common traits between different objects. This way of thinking unique to humans is called abstraction. Abstraction was not something people already knew how to do from the beginning, but rather a valuable intellectual capacity developed over a long period of time. A renowned philosopher and mathematician Bertrand Russell said, "It took thousands of years for mankind to realize that the 2 and 2 chickens and the 2 and 2 days are the same 2. This indicates that the concept of numbers that we naturally use in our daily lives was not made overnight. Numbers do not have a form, so they cannot be seen or touched. However, the concept of numbers continuously helps us count and calculate objects in our heads. Likewise, abstract numbers allow us to correspond each number with a tangible object we can see with our eyes. Thus, conditions that would allow mathematics, a subject based on the concept of numbers, to develop dramatically were met, allowing for modern science to flourish. The comfort in our lives owes itself to the study of mathematics, a subject based on the concept of numbers. Numerals are symbols that represent the amount. The ancient Egyptian numerals used symbols corresponding to every unit of numbers. These numbers developed into the Greek numerals that also symbols. Given that numerals were made out of a need to keep a record, it has a very long history. At first, people marked lines on branches or rocks. Then, with the adoption of the decimal system, which used a combination of 10 symbols of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the numbers began to have different meaning depending on which digit it was written as. Numerals can be placed in a position to mean 1s, 10s, 100s, 1000s, and so on. In other words, the decimal system began to use a collection of numbers that form a set as a unit to express it in the form of a symbol. The ancient Egyptians had the symbol system for numbers even before 3300 BCE. The numbers they used were called hieroglyphics, which were made in the figures of objects or animals. Based on the decimal system, the ancient Egyptians created symbols for the powers of 10 from 1, 10, 100, 1000, to 1 million. A vertical stick hieroglyphic symbolized the number 1. An elbow or handle was used to represent 10, a picture of scrolls or rope represented 100, a lotus flower represented 1000, a pointing finger or papyrus represented 10,000, and a tadpole represented 100,000. One million, an unimaginably large number for those who lived at that time, was represented as a man standing with his arms up, and infinity without an end was represented as the sun. Anyhow, the Egyptians continuously created new symbols for each unit and aligned the number of symbols in accordance with the number of units. This made Egyptian numerals extremely complicated. In contrast to putting down the number of symbols marking each unit, the Greek numerals used a set of completely different symbols. The numerals may look complicated at first sight, but it represented great progress compared to Egyptian hieroglyphics in that the numbers were short and concise and that there was little room for error. Still, the ancient Greek method was not suitable for representing large numbers, which meant a need to create new ways of expression. The Greek numerals used the Greek letters to write numbers. Today, Greece uses the Greek numerals just as countries in Western Europe uses the Roman numerals to show ordinal numbers. At first, the ancient Greeks represented numbers using Attica, the first letter of words that stood for numbers. This had a strong influence on the numerals, which was expressed as follows. After the 4th century BCE, the Attic numeral system was replaced by the Ionian numerals, which used the similar numerical notation system as the decimal system. New letters were created to represent ones, tens, and hundreds places. To represent various numbers, Ionian numerals needed 27 more letters. These were the 24 Greek alphabets and digamma, stigma, kappa and sampi that are not in use today. The Roman numerals were a little more developed than the Egyptian numerals. The Roman numerals are still in use today. Addition and subtraction are much easier to understand even when compared with Arabic numerals. The V shape is the shape of an outstretched thumb and index finger, and X is the shape of two verses attached together. The Roman numeral system used either the decimal or quinary system and expressed the difference in digits, placing the symbols of smaller units in front of the symbols of larger units. The Roman numerals are similar to the Egyptian numerals in essence, but it used the unique numbers corresponding to 5, 50, and 500 to reduce the inconvenience caused by repeating the same number more than 5 times. The Roman numerals were used for a long time in Europe even after the Hindu-Arabic numerals were introduced. The Roman numerals represented numbers as 1 to 10. In 500 BCE, the Romans made and used new symbols according to the place values of 1 and 5. Roman numeral I, V, X, L, and C represent 1, 5, 10, 50, 100 respectively. When a smaller number precedes a larger number, such as Roman numeral 4, 9, 40, it means that the smaller number was subtracted from the larger number. For example, Roman numeral 4 means 5 minus 1 equals 4 because Roman numeral 1 is put in front of Roman numeral 5, and Roman numeral 9 represents 10 minus 1 equals 9 because Roman numeral 1 is placed in front of Roman numeral 10. On the other hand, the Greek numeral solved the inconvenience produced in the process of writing by using the principle of place value. The first numerals using this principle were Babylonian numerals. It was the same as the numeral notation of ancient Egypt in that it lined up each unit according to the number that needed to be expressed. The Babylonians used the sexagesimal system. They did not represent each number from 1 to 59 using different symbols but just used two symbols. 1 was expressed with this symbol and 10 was marked with this symbol. These symbols were named cuneiform because the tip of them are pointed like wedges. The Babylonians marked cuneiform symbols on clay tablets, baked the tablets, and stored them. These tablets have records of addition, multiplication, and division that were complicated to calculate on them. If we change 76 from the Arabic numeral that we use today into Babylonian numerals, it can be represented as follows since 76 equals 60 plus 16. However, its usage gradually decreased because the use of the Babylonian cuneiform took up much time, and calculations with the cuneiform were difficult. The Arabic numerals, which is widely used today, is the compromise between the Babylonian and Greek numeral notations. Although 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 were first invented in India, it is called Indo-Arabic numerals because Arabian merchants introduced it to Europe. The Indo-Arab numerals were invented in India around the 4th century. The Indians who were good at counting in everyday lives used the basic concept of today's calculation like place value and positional numeral system. Even if we do not have a calculator, we can do a simple calculation with a piece of paper and a pencil. In some cases, we can even perform a mental calculation without needing to write things down. How is it possible? This is because the concept of a decimal system or place values needed for calculation are well established in our heads. These concepts were created by Indians. However, it was Arabian merchants who actually used the concept of the Indian numerals and spread it elsewhere. The Arabian merchants, who mainly engaged in trades, needed numbers and counting system that was easy to use. This is why they voluntarily adopted the numbers and counting system from India. The Arab Empire that ruled over the Middle East in the 8th century used the decimal system, the principle of place values, and calculating system by utilizing the Indian numerals and the 10 numbers from 0 to 9. Around the 10th century, the Arab numerals spread to Europe and became Indo-Arabic numerals that we use today. The last Arabic numeral invented was 0. At first, 0 was no more than a symbol representing the absence of numbers. However, after a long time, the symbol 0 established the decimal system, allowing us to easily use 4 fundamental arithmetic operations. Lastly, the ancient Mayans used the vigesimal system. They wrote numbers vertically. In the case of the decimal system, the units of numbers increase regularly as 1, 10, 100, 1,000, and 10,000. In contrast, the Mayans used the units of 1, 20, 360, and more, although they used the vigesimal system. This is because the Mayans thought that 1 year consisted of 18 months with 20 days per each month. There are around 4,000 languages all around the world today, but there is only one common notation for representing numbers using numerals. Numerals truly are a global language. Where can a variety of numeral notations be utilized? Why did we begin to use the decimal system? This is because the decimal system is easy to understand because we have 10 fingers. If we had 12 fingers, we may be using the duodecimal system instead. People in the past used the fingers to count. When they had to count large numbers, they used a pebble or a branch to mark every time they counted to 10. As this type of counting systems repeated many times, the decimal system was finally completed. The decimal system is the numeral notation in which the numbers get greater by 10 times as the place value increases. This system was influenced by India and allowed for an expression of various numbers with only 10 numerals. Simply put, the decimal system is a numerical notation in which numbers become greater by 10 times each time the place moves to the left. We can understand the composition of numbers in detail when we represent the numbers of the decimal system through an expansion using the powers of 10. Of course, the world of base systems expressions of numbers is extremely diverse. The binary system is the numeral notation where the numbers double as the place value increases. In other words, this is the numeral notation that numbers become doubles as the place moves to the left. This system can represent numbers very conveniently because it uses only two numbers, 0 and 1. The way of representing binary numbers is simple, but they end up being longer than decimal numbers. However, computers use binary numbers due to their simplicity. Computers understand numbers by changing decimal numbers into zeros and ones. Thus, the binary system is hidden in the structures of computers. The fact that the mathematical structure of computers was influenced by the yin-yang theory is intriguing. The yin-yang theory refers to the attitude that categorizes everything in the world into yin and yang, such as the sun and moon, male and female, and even numbers and odd numbers. This theory has its foundation in the binary system. The decimal system is widely used today, but the duodecimal system is a more convenient numeral system in many aspects than the decimal system. The reason why the duodecimal system is more convenient is that it has two more digits without changing place values. To give a little more specific reason, the duodecimal system has more numbers that can be divided without a remainder compared to the decimal system. A dozen, the unit used for pencils, was invented by Europeans. Surprisingly, it has also been used as a unit of time in a day. A day is 2 dozen hours, an hour is 5 dozen of minutes, and a minute is 5 dozen of seconds. Further, the duodecimal system is widely used in the system of units in the UK. Some examples include 12 lines, 12 inches, and 12 ounces. This system is also often used in the world of music. When we speak of dividing a measure or note into 3 rather than halves, it originates from the duodecimal system. Binary, triple, quadruple, and sextuple times in music all come from factors of 12. On computer keyboards that we use every day, there are 12 keys on the very top row from F1 to F12. There were 10 keys up to F10 at first, but today we use 12 keys for efficiency. The number 60 is broadly used as a unit for angles. The Babylonians, who knew that the Earth's revolution cycle was about 360 days, thought that the circular figure of the Sun was 360. They divided 360 by 6 and adopted 60 as the basic unit. The sexagenary cycle Genus used in Asia is based on the sexagesimal system. The sexagenary cycle is composed of the combinations of 10 heavenly stems and 12 earthly branches. The cycle came about from the fact that 60 is the least common multiple of 10 and 12. Genus cycle was a result of a combination between civilizations using the decimal system and the civilizations using the duodecimal system. Why did Asian countries not use all 120 names, but only 60? Thinking about the average lifespan of people in the past, living up to 120 would have been difficult, and they saw 60 years as the lifespan of an individual. This is why they thought 60 as one unit and had a huge celebration for 60th birthdays. If the Genus had constituted of 120 years, it would have been impossible to celebrate birthdays that mark having lived a lifespan. Even the novel Gullivers Travels has the duodecimal system hidden in it. The king of Lilliput captures Gulliver and provides him food and drinks that can serve 1,728 people. In return, the king has him served for the country. Why is the amount of food provided to Gulliver 1,728 servings, not 1,000 or 2,000 servings? This is because the UK was using the duodecimal system at the time. The author who wrote Gulliver's Travels thought that Gulliver is 12 times taller than Lilliputians. Because volume equals width times length times height, the volume of giant Gulliver is 12 times 12 times 12 equals 1,728 times. This meant that he needed 1,728 servings of food,